Let's begin the quadratics chapter of AdMaths. First, let's start with the normal linear equations. The basic form of a linear equation is y equals mx plus c. You've probably done this before. If not, I'll explain it right now. Y is basically y, x is x, m is the gradient. Gradient as in the steepness of the graph, and c is the y-intercept. The y-intercept is the point where the graph meets the y-axis. So if I am to draw a graph here, of a linear equation, this will be the y-intercept, and the gradient is positive gradient. If I draw it like this is the y-intercept because this is the part meeting the y-axis, this is the y-axis, this is the x-axis, and this will be negative gradient. If I draw a straight line like this is also a linear equation. Just imagine that this is straight. The gradient is 0. The reason the gradient is 0 is because there's no change in height with the changes of x. So it's a flat line, so the gradient is 0. But if the line is vertical, the gradient will be infinite because there's an infinite change in height in y and small change, next to nothing change in x. So if you divide the change in height over the change in x, you get the gradient, which is infinite or undefined, you could say. The proper word is undefined. You shouldn't use infinite in the exams or they might cut your marks. Use the word undefined when dealing with divide by zeros. So these are the four possibilities of a normal linear equation: a positive gradient, negative gradient, zero gradient, and undefined gradient. Let's move on to the quadratic equations. Okay, quadratic equations. Now, like we made the simple form of the basic equation of a linear equation, which was y is equal to mx plus c. Let's try it with the quadratic equation. It would be y equals ax square plus bx plus c. Alright, in this case, this a defines whether it will be a maximum point graph, max graph, or a minimum graph. I'll explain what those are in a moment. This doesn't do anything at the moment. This is, C is still the y-intercept. Y-intercept. There is no change in that. Now, as I said, I'll tell you what a max graph and a minimum graph is. A max graph is basically this: a quadratic graph in which there is a maximum point. This is a maximum point, so it's called a max graph. And you guessed it, what a minimum graph would be. If it's like this, there's a minimum point, so it's a minimum graph. That's all there is to maximum graphs and minimum graphs, and this is the normal way you write a quadratic equation. This is mostly how you'll get it in questions as well. Now, there is another form you can write your quadratic equations in, and that is your vertex form. I'll show you what a vertex form is. Vertex form, if you write it in vertex form, this is what you'll get. Now, this is a vertex form. The reason we call it a vertex form is it shows where the vertices are. Now, what is a vertex? Vertex is a turning point. For example, in the graphs I showed you, this is a graph. This turning point or the minimum point or maybe even the maximum point are called vertices. Now this graph, this form, vertex form tells us what the exact point of the vertex is using h and k. So the vertex would be h comma k. So this would be, if this was the equation for this graph, this point would be h comma k. Notice that there is a negative here. The negative is here because let's say if this was a normal equation, if it would be minus 6, h would be 6, not minus 6. But if it was plus 6, it would be minus 6. H would be minus 6, not plus 6. The reason being, there's a minus over here. So you're always supposed to change the sign of the value that's there. The next thing that you can use in this graph is this A. Again, the same thing for this A and this A. It tells us if it's a max graph or a minimum graph. If this were positive, it would be a minimum graph. If it was negative, it would be a maximum graph. Same here. If it's positive, it will be a max. No, I wrote it the other way around. If it's negative, it will be a max graph. If it's positive, it will be a minimum graph. You should note this vertex form down as well as what you can use here. For example, the A, what the A represents and what H and K represent. There's usually questions in which you are given a quadratic in this form. They ask you to change it to that form, and then they also ask you to sketch it or draw the vertices, etc. So this is also some easy points you can get in the exam. All you need to do is learn how to change this into this. And that's what I'm going to be teaching you next, how to turn this form into this form. Alright, let's learn how to change a normal quadratic equation into a vertex form. First things first, we need an example to work with. So I'll go with, let's say 2x square plus 8, let's do minus x plus 14. Now in order to change it to a vertex form, you'll have to follow these steps. So it's best if you note down these steps. I'll repeat them after I solve the equation as well. So keep that in mind. First things first, let's take common the coefficient of x square, which is 2. Right now it's 2, so we'll take 2 common. So it will come x square minus 4x plus 14. We'll not put 14 in the brackets. We'll only use the first two coefficients, which are a and b. Now that this is done, we'll halve the coefficient of x and square it. So what that means is right now it's 4, right? We'll make it 2. We'll divide by 2, so it will be 2, and we'll square it, and we'll add it inside the brackets. Now, in order to keep the balance of the equation, we'll also subtract it right here. We'll also subtract it minus 2 square. The next thing we'll do is take this out of the equation because we don't need it. We'll take it out of the brackets. So it will be y equals to x square minus 4x plus 2 square minus 2. There is a 2 here, so when we take it out of the brackets, we'll multiply it by 2 and 2 square. I wrote negative here because this also had a negative sign. Now that that's done, you will notice that this is in the form, I'll write it down here. If we have a plus b whole square, we can change it to a square plus 2ab plus b square, right? Right now this part is in the form a square plus 2ab plus b square. So technically we should be able to change this into this. As you can see, we have changed it to that form, and now we can easily change it back. So how we'll do it is we'll take x x minus, because this is minus we'll use minus, if this was positive we'd use positive, minus we'll skip this part and 2, because as you notice this is a square and this is b square, so all we have to do is use a and b. X is a, 2 is b in this equation, so it will be x and 2, x minus 2, and we'll add whole square. And the last thing that's left is 14 and this equation, so it will be 2 square, 4 into 2, 8, 14 minus 8 is 6, so it will be plus 6, and this is now in your vertex form. So basically let's see what we can deduce from this vertex form. This is mainly used for sketching graphs, so let's see how if we can sketch a graph with it or not. Right guys, the first thing I told you is that we can deduce the orientation of the graph using the first constant, which is a. What we can deduce from this is whether it will be a maximum graph or a minimum graph. This is positive right now, so it will be a minimum graph. Now what we know is that the graph will look like this. Right now we don't know anything else. The next thing I told you is the vertex or the turning point can be deduced with h and k. I also told you that we'll need to change the sign of h. H right now is 2, k is 6. It's negative 2 right now, so we have to change the sign. It will become positive 2, comma 6. So the turning point is 2, 6. So this point, turning point is 2, 6. So we can sketch it over here now. If this is 2 and this is 6, this is what the graph will look like. 2, 6. And the last thing we can add is, remember I told you that this c is this y-intercept. This still applies. The c is 14, so the y-intercept will be 14. So I'll repeat the steps in making this vertex form. First things first, take the coefficient of x square common. The next thing you have to do is divide the coefficient of x by 2. I'll highlight it. First you take this common, then you divide this by 2 and square it. You also have to subtract it. The next thing, you take this out of the brackets. The next thing you do is factorize this into a minus b or a plus b whole square form, and that's all you have to do. Alright, so the last thing that we'll do in this video is understand roots of quadratic equations and how to find those roots. So first things first, we'll understand what roots are. Basically, if there's a graph of a quadratic equation, let's say this, what are the roots? The roots are the points where the graph intersects the x-axis, this and this point, the x-axis. Wherever a graph intersects the x-axis, that's known as its roots. For example, if this was a graph, so these would be the roots, because that's where they're intersecting the x-axis. So now that you know what roots are, let's find out the different possibilities of how many roots can exist. Like for example, can there be 0 roots? Can there be 2 roots? Can there be 3 roots? Can there be 1 roots? So we'll understand that now. The first possibility is this. Right now it is not intersecting the x-axis at all. So there are 0 roots. 0 roots. You can also say imaginary roots. The next thing would be this. Right now it's only touching the x-axis at one point. There aren't 2 roots, there's only 1 root. It's only touching the x-axis at one point. So you would call this one root, or yeah, you could say that there are two identical roots. So this is basically only one root. The next thing, the last possibility is the most common one, which is two roots. Two roots. To be exact, you have to say two real roots. Because over here the roots are imaginary. There's zero imaginary roots, and over here there are two real roots. The next thing we'll do is how to find out how many roots there are. There's a small formula known as the determinant. I'll write that down. This is known as the determinant. Now you might be wondering what B is, what A is, what C is. If you remember, I showed you what the basic form of an equation of a quadratic was, right? Ax square plus bx plus c. These are the same things. This A is this C is this, and this B is this. So we'll use these things over here to find the roots. This is the determinant. Now that we know this, once you solve this, you will come up with a value. Let's say the value is 2, 3, minus 5, 8. It can be anything. The value can be anything. It can also be 0. Now, if the value is positive, b square minus 4ac is more than 0. More than 0 means positive. There are two real roots. If b square minus 4ac, or the determinant, equals to 0, neither positive neither negative, so it will be one real root. However, if it is less than 0 or negative, there are no real roots. Just like the possibilities I told you before, this is how you deduce from the equation how many roots there are. So if I erase this, I'll draw the graph structure over here at the side. This is for two real roots. This is for one real root. It only touches the x-axis. And this is for no real roots. It doesn't touch the x-axis. So you note this down. This is the basic method of finding out how many roots there are and if it intersects the x-axis or not. The next thing we'll do is find out what these roots are. In order to do that, you'll need to memorize the quadratic formula. This I'm going to write down the quadratic formula now. This is the quadratic formula. Memorize this by heart. This is a really important formula. Now, just as before, the B, A, C and A are the same ones from the original equation, ax square plus bx plus c. These are the same values you will be using. When you input these values, you will get two different values from the under root because there's a plus minus, and that way you will get two roots. These roots can be imaginary, they can be real, they can be the same roots. And this is, if you noticed, this is the determinant. Now that that's out of the way, this video for quadratics has come to an end. There will be a part 2 of quadratics as well, which will include quadratic inequalities and modulus quadratics.